Welcome back, ladies and gentlemen. Don't forget to subscribe, comment, like, and share. Let's try to explore some in chemistry. This is chemistry 120. So on the subtopic so-called chemical reaction. So before going further, we've got this kind of question, or let me say this kind of statement, whereby we have ammonium reacting with the nitrate to produce nitrogen oxide, or let me say dinitrogen, which is nitrogen gas, plus 2 molecules of water. Not only that, I've got a table here which showing the concentration, different kind of concentration, or especially the reactant. So one thing I'm supposed to know here is that we've got differential reaction. We have differential reaction or differential electro and also have integrated electro. So what's going to happen here to determine those kind of things? By the way, we're still lying on the question which is trying to say ammonia reacting with nitrate producing nitrogen gas plus 2 molecules of water. Just to relate it, of ammonium reacting with nitrate to produce nitrogen gas as a product plus 2 molecules of water. So you have to make sure that it is balanced. You have to make sure that everything is balanced. Both reaction, either forward or backward, everything has to be balanced. Hence, what is the question on the table? Light the integrated electro, differential electro, determine the value of x, which is we're talking about now the value which is the overall, and also determine the overall order of the reaction. So what I want to talk about, value of x, that is the order of the reaction. Now, what are some of the things we're supposed to bond with it in mind when you say integrated electro? We talk about the lead, which shows the concentration of the reaction depend on time, and also differential electro. It is the lead or law, which shows how the concentration of the reactant, or let me say how the concentration depend on reactant. So what's going to happen here is, that means to say, if you start with differential electro, here you are setting to say lead or should I start with integrated? So that means to say this is how A, this is how B, based on the question. So based on the question, relying on the question said to say, number one is integrated electro. So what's going to happen if you start with integrated electro? So that clear said to say, depend, or let me say the electro or the integrated electro, this is the law which shows the concentration which depend on reaction, or the concentration which depend on reactant, and is moved with time, or is moving with time. That's why in this reaction, on this law, you have to make sure that everything is balanced. Hence, we say lead is equal to negative. Why am I trying to put negative? Or not to say, always the reactant keep on reducing based on the reaction here. So always the reaction keep on what? The reaction keep on reducing, hence I'm going to show a negative as one of the decrease or sign of decreasing. Then product, or to say, is always keep on what? Increasing. Now, that is another the discussion of the day. So what's going to happen here once you try to do this? We say negative symbolizes to say this reactant. Then change these blankets representing the concentration in ammonium divided by change in time. So this is our integrated electro. Again, since we've got two reactants here, let's change in nitrate divided by change in time. So I have to make sure that everything's in order and also make sure that the reaction is balanced. What if, for instance, here we try to put, or let me say it was being balanced in this case, that could have been affected all the integrated electron, whereby it's a late or integrated electron is equal to now the balance, which is the mole ratio, which is in front of ammonium, affecting everything. Hence, the 1 we maintain the 1 divided by 2, as in the mole ratio has been used to balance. Then negative we maintain 1 and the same because that's a reactant. Change in reactant, which is ammonium, divided by change in time. So that was just one of the example. So not that integrated law and differential law, most of important that we can value is a reactant, because without reactant we do not have anything. Thank you very much. What about the next question? This is just talking about what? The differential value of X. Let me say differential electron. Shall we? Let's go. So what about differential electron? So differential electron, we know to say differential is just the rate, or let me say the rate which depend on the concentration, or let me say describe the concentration which depend on the reactant. Hence, the reaction constant is very much important, and also the order reaction is very much important. How and which way? Note that regardless of everything that we're trying to put, regardless of the law, we know to say reaction are the very much important, because as they're trying to reduce by symbolizing negative, they're trying also to stimulate the appearance of the product, which shows positive. Now in this case, what's going to happen, we're going to have rate, which is differential electron, is equal to K as in reaction constant, then concentration is represented by brackets. Then what's going to happen, of course, that kind of reactant. Do we have anything there? We do not have. So we put B there because we do not have. We're supposed to have. So we do not have anything there, because the order of the reaction depends what type of reaction is that. What type of order is that? Is zero order, first order, second order, or third order? So what's going to happen again? We've got another second reactant there, which is nitrate, represented by B. So this is the differential rate. So what's going to happen? How can we differentiate from differential and also integrated? So integrated, note that this is just a rate which shows how concentration depends on reactant and also with time. Then the differential only shows how the reaction or how the rate depend on the concentration with especially on a reactant perspective point of view, without time in this case, but mostly involving the constant, reaction constant, and also the order of the reaction, of which in integrated we do not have such kind of things. What will be the next question? The next question just about determine the value of what? Determine the value of X, as in the third question. So determine the value of X, of which, quite interesting. What is the next step here? Impose to say, what's the purpose of this table? Or what's the purpose of this table? So what's going to happen, you have to pay very much attention for to calculate the value of, or let me say for to apply this method, or for us to calculate the value of A and B. So in this case, what I'm trying to say is that for us to find the value of B, that simply means we determine the value of X. So how are we going to determine that? We use this table. Hence, pay very much attention to this. How are we going to utilize it? Should I give you the value, or let me say, should I give you the key? Here it is. So that means to say, if you try to cancel, let me say, if you try to find the value of B, that means to say we're supposed to have, here it is the value of B. The value of B is, if you try to find, for instance, to find the value of A, that means to say you're supposed to find the coordinates, or let me say the concentration, which is lying in the same way, the reactant and also the product, or where they are meeting. And in this case, for instance, if you're trying to find the value of B, that means to say we have to use this coordinate, because 2 and 1 under ammonium, they are meeting at what? 0.1 100 molar. Then we can calculate for nitrate. Same applies to nitrate. We do the same thing, lying on the same line, or let me say passing or meeting at 0.01 molar. Also, we do the same thing to calculate, or as we're trying to calculate the value, let's say the concentration, or let me say the overall charge, should I say the order of the reaction for ammonia. Now, what's going to happen here is, if you try by all means to calculate for nitrate, that means to start going to use experiment 1. Note that we only have exact numbers here, but do not have the decimal numbers. We do not bring decimal numbers here. We just want exact numbers. So that means to say, no improper fraction here. So we're going to have first or second experiment, because we're going to have high value on top, a smaller value on top, as initial rate for experiment 2 and 1. And also same applies to nitrate. We're going to have the high molar on top, as in down the smaller one. Then also the same applies to ammonia. Okay, so that means we're going to use experiment 1, experiment 2, divided by experiment 1. Okay, shall we? Let's go. So this is experiment 2 divided by experiment 1 is equal to constant. Note that we are still under differential. Then concentration of ammonium divided by concentration of ammonia, same thing, because we have the top one and also the bottom one. So for instance, we label the same thing that we use the letters A, same applies to the same thing, nitrate, B, and also lead constant nitrate, B. So what's going to happen once you try to do that? Note the figures if you try to get a little bit here. So experiment number 2, we get the initial rates, which is of course 2.70 times 10 exponential negative 7. Same applies with 1.35 times 10 exponential negative 7. So as in experiment, we use initial rates. So what is experiment 2? That is 2.7 times 10 exponential negative 7 divided by what is experiment 1 as an initial rate, that is 1.35 times 10 exponential 7 is equal to, let me say, what is rate constants we do not have, so that means there's no use of it. And what is ammonia? If you see very much properly, we've got the bottom and also the top one topping with 0.10 molar as in equal. So that is ammonia. So that means also giving out a chance to say calculating for nitrate. So for ammonium of 0.100 molar, as in B here, and also 0.100 molar, as in A, same applies with K, so K as in lead constants, we try to forget a little bit about it. What about nitrate? Nitrate also topping with 0.01 as in molar for experiment 2, then divided by 0.01 or 0.05 molar, as in the one that is topping on top. So which means I'm going to have 0.010 molar divided by 0.005 molar. So that is B. So if you see very much properly this code, so what is this divided by this? Hence we're going to have figures such as if you punch it very much properly, you find that you are holding 2.70 exponential negative 7 divided by 1.35 exponential negative 7. So what is your answer? We remain with 2. Also same applies here, we remain with 2, hence B. And what's our answer in this case? We're going to have 1. So that is our answer for B. So in this case here, that's a replacement of B. Yeah. Same applies to the same thing. We do the same thing, the same procedure. We do the same procedure or the same thing to find the value of K. Yes, if you calculate very much properly, That will be your assignment. So please, that should be an assignment. Do the same thing that I've did, or let me see what I've done. It'll be easy for you to calculate it and also to find the final answer for value of A. Hence, what will be the final answer you're going to have? Rate is equal to K as in lead constants, then ammonium. Then here also the value, let me say the overall chart, let me say the order here is 1. It's given us 1, the same thing. So just leave it like that. That means to say we have 1. And also nitrate here also 1. Okay. So that will be our final answer. So do the same thing to confirm what I've done there. So no need of putting this, just the same thing. Okay. Determine the overall order of the reaction. That means to say the one that we have here plus the one which is B plus the one for A, that will be the overall order of the reaction are going to have 2. Yeah, that is it. So please make sure that you go through and also make sure that your answer for A, we try to confirm if it is truly is 1. Yeah, same reaction, let me say same method. Yeah, otherwise, thank you very much. For those, for instance, who want to try to find out the value of, or let me say, the late, as in late constant. So we go back, of which are going to have late, using the same formula. Late is equal to late constant, ammonium, and also nitrate. So what's going to happen here? The late, you can use any initial late. So which means, for instance, if you use any initial late, you're going to use any both nitrate and nitrate lying in the same line. So for instance, if you use initial late, you're going to have, that's an additional question, 1.35 times 10 exponential negative 7